This lesson is about finding the area under the normal curve. If you have a probability density function, which is normal, and if you have your z-score, should be able to find the area under the curve. The things that you need to know before you go into this lesson is you need to know how to find a z-score. You need to know the properties of a density function. You need to be familiar with the location of the mean and the standard deviation on the curve. In this lesson, what you'll be able to do by the end of it is be able to find the area under the curve for a z-score if it's less than a positive number, for a z-score greater than a positive number, for z being greater than a negative, and for z being less than a negative number. Now the first two examples, find the area under the curve for z less than a positive, find the area under a curve for z being greater than a positive number. Another thing that you'll need is a table like this. In this table is the standard normal probabilities. What this table represents is all areas that are less than a number on the table. When you find your z-score, you're going to have usually a z-score that has 2 decimal places up to the hundredths place, and you also may have a ones place. Here's how you read the table. You take your first number, 1, and then the tenths place after that, and you find it in the column here. Then the hundredths place is going to be on the row. So for example, when we're going to find 0.83, we're going to first find 0.8 here, and then since 3 is in the hundredths place, we're going to go across and we're going to find a value of 0.7967 for that. So once again, this is all less than a positive number. So with that in mind, the first problem, you can simply use the chart, but I want you to understand what you're doing. So here's how we approach these problems. The first thing you do is you draw out the normal density function. Just a little model will do. You know that the mean is in the center, so the mean represents standard deviation of 0. The z-score you got was 0.83, so we're going to make a mark to the right side of the mean, and that's going to represent 0.83 because 0.83 is positive. Positive numbers go to the right of 0. The area that we're interested in is going to be less than 0.83, so we're going to shade in all of this area here. And notice that it's most of the area under the curve. So it's going to be a large number. So what we do is go to the table. Since the table shows areas that are less than a certain z-score, we're going to look for, again, 0.83, 0.8, and then come across to 3, we get 0.7967. Okay, so the area under the curve is 0.7967, and you know that one of the properties of a density function is that the entire area under the curve is 1. We've shaded most of the region, and 0.7967 is pretty close to 1, and there's only a little bit of a portion that's not shaded. The next one we're going to do is z is greater than a positive number. So again, the first thing to do is draw out your density function, the graph of it, label where your mean is, and then we're going to make a line for 1.51, approximately where that might be, somewhere in here probably. But then instead of shading to the left, we're going to shade to the right because z is greater than 1.51. Greater than, we shade above. Any values that are above 1.51 will be over here on this tail. Okay, so you can see that in this tail, it represents a small portion of the density function. The density function, the entire area is 1. So what I want to do is I want to find this area. And this area is not in the table, so we're going to have to do something with what we call the complement. The area in here, we'll call that A. And let's call this area B. And we know from the property of the density function, A plus B is equal to 1. So what I'm trying to do is I'm trying to solve for B. So if I just take and subtract A from both sides, I get 1 minus A. That will give me B. Okay? So the other question you may have is A findable? Will we be able to find A? Well, if we look at what A is the area that is less than a certain value, and that value is 1.51. So if we could find the area less than 1.51, we can also find B. And fortunately, the area less than 1.51 is in the table. So 1.5 and then 1 is 0.9345. That's section A. And we're going to subtract that from 1. And when we do subtract that from 1, we get 0.0655. So the probability for z greater than or equal to a positive number, and that positive number being 1.51, that area is 0.0655, and you can tell again the entire area under the curve is 1. This is a small tail that's been shaded. This is a small number when you're comparing it to 1. Okay, next we're going to do z is greater than a negative number and z is less than a negative number. So if we're going to tackle the probability of z being greater than or equal to a negative 0.96, again, the first thing we do is draw out the density function. Draw out where your mean is. Mean, again, represents a point of 0. And then let's find out where negative 0.96 is. Negatives are going to be to the left of 0. And then the area that's shaded is greater than. Anything that's greater than negative 0.96 is going to be to the right of it. You can see that we shaded more than 50% of the curve, so the area is going to be more than 0.5. The way that we're going to do this one is the normal curve is symmetrical. So if you can imagine that I'm going to rotate this whole thing around. Okay, if my hand was the normal curve, if we rotated it around, what would it look like? If I rotate this around, I'm going to have 0.96, and instead of shading to the right, it's going to be shaded to the left. So the first thing you'll want to do is rotate the normal curve and draw it. Okay, now what we're looking at is a shaded area that's to the left of a positive number. That was the first case that we did today. That's going to be the same as z is less than 0.96. We can find that from the table. So find 0.9, go all the way over to 6, and you get 0.8315 for the answer. Okay, again, our projection was it's going to be greater than 50% of the curve, and 0.8315 is greater than 50% of the curve. The last case is going to be if you have z being less than or equal to a negative 0.47. So again, we're going to draw the normal density function, put in our mean, put in where we think 0.47 is, It's negative. And z being less than a negative, anything that's less than a negative is also to the left. So if we look at this critically, you see that less than 50% of the area has been shaded. So our answer should be less than 0.5. Again, we're going to do a rotation. So because of the normal curve is symmetrical, we're going to rotate it around x bar and redraw the diagram. So we've rotated it. Here's x bar in the same position. 0.47 from the mean. The area that was shaded when we spun it around now will be this area. So as you can see, less than a negative is going to be the same as greater than a positive of that same value. And how do we find greater than a positive? Well, we've already had that case. We're going to take 1 minus the probability that z is less than or equal to 0.47. So find 0.47 in the chart. 0.47 is going to be 0.6808. And then 1 minus 0.6808 is 0.3192. Okay, in summary, what you learned in this lesson was you learned how to find the area under the curve for a z-score less than a positive, for a z-score greater than a positive, for a z-score greater than a negative, and for a z-score less than a negative. As you do more examples, I'm sure it'll become clear to you, and if you didn't quite get what this lesson was about, just go back and watch it again.